So let's look at defining each of these. Filtered load, we talked about filtered load before. Depends on how much stuff, what stuff, in this case X, how much stuff is in the plasma and how much fluid is filtered out of the plasma into the glomerulus. So my filtered load, represented in as amount per unit time, yes?
I put on the slides to write this down then.
Have you looked in the slides that I updated yesterday?
It's in the newer one. I printed this
Okay.
Yeah, this was on Monday.
From chapter 18 or from, anyway, it doesn't matter. Okay,
Write it down. Write it down.
well, I'm gonna go through this pretty quickly. So, but it's gonna be recorded, so you guys can go back and listen to it, okay? I wanna get through one example. Okay, this we've already seen, right? Okay, when we look at excretion rate, then we're saying, okay, well, at first this seems like it should be excretion rate, right? How much what the concentration is in the plasma and how much of it is filtered out. But excretion has two other steps that occur before we leave the body. We have filtration, we have reabsorption, and we have secretion. So when we're looking at excretion rate, what we're looking at, what's the rate of urine flow and what's the concentration of our solute in the urine. And the concentration of solute in the urine is not necessarily the same as the concentration that was filtered because of secretion and reabsorption. Okay. So, how do we know how much is actually excreted? Well, the amount that was filtered out of the blood into the renal tubules, the amount that was secreted out of the blood into the renal tubules. We add those together because that's how much went out of the blood into the renal tubules. We subtract from that how much went back into the blood, and what we're left with is how much is actually excreted. So it depends on my filtered load, how much comes out during filtration, my secretion rate, how much gets secreted out of the blood into the plasma, out of the blood into the renal tubule, and reabsorption, how much it goes the other way. Okay, really quickly. If the amount that is filtered is the same amount that leaves, there's been no net change. Doesn't mean that there wasn't any filtration, it doesn't mean that there wasn't any secretion or any reabsorption. It just means if my excretion is the same as what I filtered, however much was secreted was reabsorbed. If the amount of solute excreted is less than my filtered load, that means that some of it had to be reabsorbed. Because I took out X amount and I'm leaving with less than X amount, so some of it had to be reabsorbed. Conversely, if I excrete more than was filtered, more had to be emptied in. So let me do this diagram and then we'll stop. Okay, so here's my renal tubule system. Obviously super simplistic, right? Okay, a lot of folks are recording it. If you want to record it, you can do that. So here's my afferent arterial, very basic diagram of my glomerular capillary, efferent arterial, peritubular capillary, Bowman's capsule, and this represents proximal convoluted tubule, loop of Henle, distal convoluted tubule. All right, so I'm going to start by looking at water. Under normal circumstances, I have about 600, 625, whatever, mLs of water flow through my glomerular capillaries per minute. This process, filtration. How much gets filtered? I know this is 120, it should be 125, okay? About 120 mLs. Is any additional secreted? No. So then my water total, the filtered plus the secreted, is still 120. So filtered and secreted, I'm still at 120. Then I want to look at how much is reabsorbed. How much is reabsorbed? None. I'm sorry, none. That would be a lot of peeing, right? That was the whole problem. How much is reabsorbed? Almost all of it. 118 of that 120. So when I add 120 plus 0, subtract the 118 that went back, how much is left at the end of this? 2 mLs of water per minute, and that's my water excreted. Now let's look at if we have a solute in there. What solute? Let's call it solute X. I'm just going to call it solute. So let's pretend that the plasma concentration of my solute is 0.8 milligrams for every 1 ml. That means for every 1 ml of plasma, I have 0.8 milligrams of this solute. So what's the first thing we're going to do? Well, the first thing we're going to do is we're going to filter. When we filter, we are going to filter out 1.2 milligrams of that solute. Then what are we going to do? We're going to look at how much is reabsorbed. I'm sorry, secreted. How much is secreted? We're pretending. Let's say it's 0.3 additional secreted. So this is the amount filtered from blood to kidney. This is the amount secreted from blood to kidney. So my total amount at this point that is in the kidney is 1.5 milligrams of solute. All right, but we have one more thing to worry about. What do we need to worry about? We need to worry about reabsorption. Is any of it reabsorbed? Sure. In this case, I did 0.6. I could make these numbers up, and I may very well have. I don't remember. So let's say 0.6 is reabsorbed. So then, when I want to look here, I take my 1.5, which came out of the blood into the kidney, subtract the amount that went out of the kidney back into the blood, and what does that leave me with? That leaves me with the amount excreted, which is 0.9 milligrams of solute. One more minute. But when we're looking at this, we don't want to look at solute or water. We want a concentration. So we have to look at these together. So we start with 0.8 milligrams of our pretend solute per 600 mLs of water. After filtration, I end up with 1.2 milligrams of solute per, just going to stick with these, 120 mLs of water. That brings me down here. Then what are we looking at for secretion? No water, 0.3 of our solute. So of course we're going to total these up. I've got 120 mLs of water. I've got 1.5 milligrams of solute. Now I want to look at, so those are just these numbers here. Now I want to look at the reabsorption factor. We said for my pretend solute, we reabsorbed 1.6 milligrams. We reabsorbed 118 mLs of water. So I'm going to do my subtractions. This minus this gives me my 0.9 that we looked at before. This minus this gave me my 2. that I looked at before. So my excretion, it's 0.9 milligrams of solute per 2 mLs of water. Did I miss one? Why did I, hold on. There we go, that's the part I wanted. So, to figure out my final filtration for solute X, I have, that should be 0.9, must have gotten cut off, 0.9 milligrams of solute per 2 mLs. When I divide 0.9 by 2, why do I have 9? That should be 0.9, that should be 0.45. I'm sorry guys, I was trying to get the numbers to work and obviously I didn't do a good job. But I can use this to say, okay, how much should I filter? 1.2 milligrams per 120 mLs. How much did I secrete? 0.9. Therefore, if this is less than this, I had to have a net reabsorption, which I did, right? Thank you all so much for being patient. We will get these posted